Hello and welcome back to this lecture series. So in the last video, you just learned about the reference variable and the pointers. Now, in this video, let's implement all that concept which I have promised in the two videos. Now, call by value. So this is a simple program for a function. Here, I'm going to declare int m equals to 100 and I'm going to pass 100 to this variable, sorry, to this function. So now this is a pretty straightforward calling. So that is call by value. I just pass a value to this function and that is handled by this function definition, and whatever the value of m, okay, sorry, I should put m, one and the same thing. So that 100 is copied to the x is equal to m and m is equal to 100. So x is 100 in this current instance and it's going to print the x. So okay, uh, void v expected semicolon. Okay, I forgot to put a semicolon over here. Okay, let's compile and run our program. And now we are having 100 over here. So now this is call by value. I just pass a value to this function, to the function definition. So here I'm calling, as the name suggests, call by value. I'm calling this function with a value. So now let's use call by pointer. So here call by pointer, rather than capturing a value, here I am going to declare a pointer variable. So here x is a pointer, so if I'm going to see out x, it's going to give me the address, but I want to deal with the value. So here I'm going to put star x to print the value. Okay, so now let's compile our program. So it says that invalid conversion from int to star. So now, as I stated, that this is the actual argument and that is going to copy into the formal argument. So here virtually what it's going at the back end, it's like int star x equals to m. So is this right statement? As we already discussed, that this is a pointer variable and here I should give address, not a value. Here m is a value, so here should be what? Ampersand m. So here in a function call, rather than giving a value, I'm going to give the address of m. So now I'm going to compile it and execute it. So it's 100. So working is correct. So what's the difference between these two, call by value and call by pointer? The difference would be clear if I'm going to write cout, one more cout statement over here. If I want to say that after function call, the okay, after function call m equals to, here I'm going to write m. Okay, so I make a function call, so this value is going to print and I'm going to put a new line over here. So this is an alternative method to put a new line. Now if it is called by pointer, so look, I'm passing the address of m. Okay, so now if I'm going to change something inside the function, let's suppose star x means I'm going to change the value. I'm going to give a new value to this x. X is just an address, and whenever I'm putting star x, it's referring to the value of that particular address. So here, if I'm going to give some value 99, 99, so now here, if I'm going to compile and run, so I will have a 99 even inside a function, and the actual value of m is also changed in this particular case. Here I make a function call and I'm passing the address of this M. Here I'm saying that star X means X is pointing to the M. I'm picking the value of M and I'm putting 999 to it. So this function is going to print 999, and after that the M value, which was 100, but here it is updated because X is referring to the M. So your actual value change. So in call by reference, we are dealing with the actual value. So now let's change our scenario, same scenario, to the call by value. So here it's a call by value. So instead of address, I'm passing the value. But here I have declared a pointer. But here for call by value, all should be the simple values. So what should I expect in this case? So here I updated the value of x, but you can see that x is a local variable over here. So whatever I'm going to make change, that is going to change in a local variable x. It's like int x in this call by value. It's like okay, removing this and this. It's like this. So here I'm working with the x, whereas m is still unaltered. So here, whenever you're printing the cout inside this function, the value of x is 999, but your m value is preserved to the 100. So here, this line will call whole this code, and your 999 is printed over here as you are working with the x only. And here cout, it's responsible to print the value of m, which is preserved to the 100. Now you can see that this is our output 999 and 100. So in a call by value, we are working with a copy of our original value, not with the original variable. Okay, I hope it is clear. So I'm going to move now call by reference. So in a call by reference, everything is the same, but if I'm going to put ampersand over here, let's see what will happen in this particular case. So you can see the both value are the same. So the effect is equivalent to call by pointer. So let's see that how this is working. So here I pass the m over here, call by value, simple statement. But here when I'm putting this ampersand x, it's like int ampersand x. We already learned that this ampersand x will give a alias name to the m. Either you will work with a x or a m, it's referring to the same memory location or a same value. That's all about the functions, call by value, call by reference, and call by pointer. So in the next video lecture, we are going to deal with function overloading. Keep tuned and subscribe for my channel for our latest updates and videos.